All right, we're going to take a look at a topic called regression here. And we're going to look at a couple ways. We're going to use Desmos calculator, which you can find at desmos.com/calculator. And we'll use that, and then we'll also show you how it works on the TI-84. All right, so a lot of this is just kind of going through some steps. So we're going to kind of go through this kind of quickly here, all right? And we'll be using this throughout the term. So this is just really an introduction, all right? So when we have an equation and we find values of the equation, you know, if we have y equals 1/2 x plus 3, and we go plug in numbers for x and we solve for y, that's a standard use of a function there to get a table, and then from a table get our graph, all right? So when we want to go in reverse, when we have an application, we have situations where we know the points, but we don't know the line. So what our goal is going to be here is we want to take some data points that seem to be in a pattern, and we're going to find a line that goes through those points. It'll hit some and miss others, but it will kind of average those points out. So given some points, we want to find the equation that fits that. That's called a regression equation, all right? So going to go through some steps here, and we'll see how this works, all right? So first I'm going to use Desmos, which is an online tool, or there's an app as well. So let's open this up here. If it will let me. Let's try this. I don't think it likes it because we're recording. Oh, here it comes. All right. So we're reloading. There we go. Now we should be good to go. All right. Now we got our Desmos. Great. So here's what we're going to do. I'm going to go through some steps. We're going to enter some data, and then we're going to ask the calculator or the computer for some equations, all right? So first thing we're going to do is we're going to take some data. So here we have some data about some, these are some crickets that are chirping, all right? So we're going to add a table, and so we'll start by just entering these, and this should be, notice the x1 and the y1 up top. All right, and so this is our x1 table, the x coordinate, the input coordinates. And so we'll enter all these, 14.7, 17.1. Data entry is a little tedious sometimes. That is just part of statistics. And 71.6 and 93. Got to be careful here. It's really easy to make mistakes. You might want to double check your list. I'm going kind of fast and talking at the same time here. So, high probability that one of these is a little off. All right. And I think we got it. There we go. All right. So now we've entered our table here. And now what we're going to do is first we want to find it on the graph. So if we zoom out, there they are. Okay. Now on what you can't see is I'm on a tablet, so my fingers, I'm doing kind of a pinch and a expand here. Or over on the right side, you can use the plus and minus there. Or you can go to the settings and you can set your X and Y axis to what you want to see. So there's our points. All right, so that is what we call a scatter plot. We want to get an equation that fits that. So what we're going to do is we're going to type this command here, this equation, and we're going to type y1, and instead of an equal sign, we're going to put this little squiggly sign, this little tilde. And so what that tells us is that we're looking for the equation that kind of approximates mx plus b, a line that approximates these points. If you want to do a quadratic, you would do this. All right, so let's go ahead and do that. So I'm going to type y1, and when you type 1 after the y, it underscores, all right, and everything just closed on me. There we go. So y1, and now we're going to go, which is on the computer there, on the keyboard, m, then we got x1. We've got to do x1 here, not just x, and then we need plus b. So this is our slope-intercept form of a linear equation, y equals mx plus b. And what we get are these values here. So we get a value down at the bottom here for m is 4.02-ish about, and b is 11.30. And so we entered the data, okay, and the equation we got, this is what we call the regression model. The regression model is the equation. And so our equation is y equals 4.02x plus 11.30. Okay, around to 2 decimal places is good, or sometimes 3. But that's the equation that fits the points, and it's graphed here on Desmos. Now, if we want to use that to predict 10 chirps per second, the temperature, we have to realize that y is the temperature, and 10 would be the x. So we're going to take our equation, and we're going to type 4.02 times 10 plus 11.3. And we got 51.5. So this would be our value when x is 10, y is 51.5 degrees. Okay, so these were degrees. Oh, I'm guessing it's Fahrenheit. Probably told us somewhere there. Okay, I think it's Fahrenheit. Now, if we wanted a quadratic equation that fit this, we can do that. Now, notice this r squared value. I can't really point to it, but this r squared value, actually the r value we want, is 0.9. So the r value is 0.9. What that tells us, 0.911. That is called the correlation. That is how closely it fits. If that number was 1, it'd be like a perfect fit, like 100%. So this kind of is like a 91% fit. That's pretty good. All right, so we want that to be close to 0.9. Now, if we wanted to get a quadratic equation, the way we would do that is we would again type y1. We do our tilde. And we're going to enter this general form of a quadratic equation. So we're going to do ax squared plus bx plus c. All right, now, see, it's not liking that because I already got the y1, so I'm going to delete this y1. All right. Oh, actually, what it doesn't like is it doesn't like the fact that I didn't enter x1. These have to be y1 and x1. There it is. So there's a quadratic equation. Now notice this r squared value is 0.84. That means it's not as good. That's not very close to 1. So the equation here is y equals, now if we scroll down here, we've got an a value of negative 0.36 we can round off. That's in the a spot. Then the B spot is 16.45, and that's X. And then the C spot is minus 96.22. Now, we'll talk more about quadratic equations later, but the reason why it's quadratic is because it has a squared on it. All right, and so our residual here, now notice this has an r squared. R is not even an option. And we won't go into that, but that has to do with the fact that it's quadratic, not linear. So that's 0.84, so it's not quite as good of a fit as this one here. All right, so we'll, but that's what that is. So if we want to use this model, so that's a quadratic model, what we can do is we can go, we're going to take this equation, ax squared plus bx plus c, and we're going to enter 10 in for that. Now, I'll show you a little different way. Now, I could type this thing exactly with those decimal values, but I'm going to do this. I'm going to go ahead and type the variable a, and what that does is that grabs, you see that negative 3.35 number? That's up here, right up above. So that's the variable. That's grabbing the number from up above. So I can do ax squared. Actually, we want to do ax1 squared. Okay. Plus, and then instead of typing the 16.4 number, I'm going to do bx. And then plus c. And I need this to be x1 again. All right. What's going on with this picture? Y equals bx squared, bx1 plus c. So that should do it for us. It's kind of doing something a little odd. We got x1, y1. I wonder if that's... Oh. Yeah, there we go. Oh, I'm sorry. What I'm doing here, let's back up. Okay, I forgot. We're doing this for 10. I kind of lost track of where we were. Sorry about that. It's been a long day. All right. A, and then we're doing this for 10. That's right. We want to evaluate this for 10. That's what we're doing. I already did the approximation. I was redoing that. So anyways, we have x equals 10. When x equals 10, y is going to be 32.78. So you see it predicts a little different temperature because this is a different model. All right, and so we have to decide based on things we know which one would be best. All right. Well, we can also do this using our calculator. Now, our calculator is a nice tool because it's portable, and so we'll look at some steps, but sometimes the steps get a little tedious, but we'll go through them kind of quickly here, and since it's on a video, you can pause and rewind and rewatch it. So let's starting up here, okay? So here's the steps. This is what we're going to do, all right? Now, this is a calculator emulator, so it's not 100% exact, but it's pretty close. But it works so we can record this here. All right, so here's what we do. To enter the information, we're going to go stat, and we're going to go to edit. Now, notice I have some numbers in here already. So you should have some lists like L1 through L5. And so to get rid of this, we're going to go up and hit clear. Okay, so you go all the way up to the top to L1, hit clear, and go down. Do not hit delete, hit clear. And now we still have L1 and L2 up top. All right, so what we're going to do is we're going to enter the data. So this will take a moment again. All right, so I'm going to enter these one at a time carefully. So we have a few steps. One is to enter the data. Then we're going to get a scatter plot. And then we're going to 8.4 and 16.2. All right, so after we do this, then we're going to get a scatter plot, and then we will get our regression line. Now, you don't have to do a scatter plot to get a regression line here. You can get the equation without the graph. Sometimes we like the graph, sometimes we don't need it. A lot of times we don't need it, actually. 75.2. All right. All right, so let's see. I got to double check because one of them's off. I got 88.671. I missed the 93. So if you miss one, here's what you need to do. Notice I missed the 93. So I'm going to insert. So there's a delete key in the middle here. So we're going to hit, and insert is above it. Anything that's above, we got to hit the second key. Second and insert. Notice it put a 0 there, and I'm going to replace that with 93.3. And now the bottom of the list lines up. We got them all. Make sure that bottom of the list signs up. If you want to get out of here, we're going to go to second, quit. Oh, what did I just do? I think I deleted it. Let me enter that one more time. 93.3. There it is. Second, quit. All right. So we've entered the numbers here. Now we're going to do this. If you just need the equation, then you don't need. You can skip these steps of creating a scatter plot. All right. So this is optional. Sometimes it's nice to look at the graph. Sometimes we don't have to. And here's the steps. Again, got to go kind of quickly, but you can pause and rewind. So what we're going to do is we're going to go to stat plot, which is above the y equals key up on the left here. Okay, mine just says plot, but it'll say stat plot on yours. First thing we're going to do is we're going to go turn it on. So we're going to select on over here on the top left and hit enter. Pick your favorite color if you have a color option. Most of us don't actually. Now we want a scatter plot. That's this first little graph. We're going to graph a bunch of dots. And it should say list 1, list 2. Those are the two lists we're using. And we're ready to go. Now if we go over to graph, let's go to graph. You're not going to see much. Okay? And actually it'll probably look like this. All right. So now I got something on this is my y equals key. If you hit your y equals key, you got to make sure that there's nothing here in these equations. Okay, so now I go back to the graph. I don't see anything. So what we got to do is we got to go to zoom, and we're going to scroll down until we have zoom stat. So this is going to look at the statistics numbers and zoom in on them. So zoom stat. All right. So we did stat plot. We chose one. We turned it on. Okay. And last thing we go zoom stat, and it shows all the points here. All right. There they are. So now we need to find the line that goes through that. Okay. So we're going to find the regression line. Again, that was optional. You don't have to turn on that graph to be able to get the equation. So now to get the equation here, down on step 10 here. So we want to go to stat and calculate. So we're going to go to stat, and then we're going to go over to the right here to calculate. And we want to calculate the linear regression. So the key here is we want linear regression or quadratic regression. Okay? And so we're going to go down and go linreg. Okay, linear regression. And it'll have list 1, list 2 in there. Okay? And we can hit enter, and there they are. Now let's compare that with what we have up here. Okay, notice those numbers are the same. 4.02 for the A value and 11.3 for the B value. Okay, and again, the R value came out to be 0.911. Okay, so that's how we do that. Now there is one other step here. If we want to store the regression line, this is optional. Okay, if we want to store the regression line, I'm going to go back to stat, calculate, and I'm going to go down to for linear regression. There it is. Okay, now you may have this menu, you may not. All right. And if you don't, then you can still do what I'm about to do. You just type it right at the end of the parenthesis up top. So we can store the regression in equation y1, and here's how we do that. We're going to hit vars, going to go to function, and y1. This is going to tell it to store the equation into the y1. I'll hit enter. Now we go to the y equals key, and notice there's that equation up in the y1. And if we go to a graph, there you go. There you have the line and the points in the same one. Okay? All right, so that's the idea. That's how it works. I got one more quick example I'll do just to show you how the calculator works. Okay, so I'm going to go all the way up to the top. I'm going to clear my list and go down. I'm going to go up, going to clear my list and go down. And now I'm going to enter these numbers, which is a lot smaller. 1, 2, 3. And then we've got 0, 460, 460, and 925 and 1300. Okay, these are heights. What are these? Of a rocket, measurements of a rocket at different times. Okay, so there's my points. If I go to graph, I won't see it. I'm going to clear this y equals. Okay, so the graph is gone because I got to go to zoom stat, number 9. Okay, now the stat plot was already set up because I set it up a moment ago. I just changed the numbers. So let's get a quadratic regression. So if I go to stat, go over to calculate, and go down to quad reg, number 5 there. See that? Quadratic regression. If we want, we can store that in Y1. Go down here to store regression equation, reg EQ. Go to vars, function Y1, and we punch that in. And this gives us an equation. The equation is y equals, our A value is 21.25. You see that up there? Plus 500.25x minus 4.75. Okay, and the R value is 0.99, so that's a pretty good fit. Okay, now if we want to use this to approximate the maximum height, what we could do is we can go to graph. Okay, and now we'd have to do something like this: zoom out, zoom out. Okay, I'm trying to find the peak of this. Okay, now there's a way to find a maximum. Whoops. Second quit. Zoom out one more time. Okay, so the way to find the highest peak, because this is going to be going up and it's going to start going down. You see how it's starting to go down a little bit there? There it is. All right, so if we want to find the peak of this, what we can do is we can go to, where are we going to go? We're going to go to calculate above the trace key here. So second, calculate, and we want the maximum, the highest point. Okay, and so it wants to know, it wants a guess. So we have to go to the left of what we think is the maximum. And if you can see the cursor kind of going up on the arch, I'm going to the right, and I'm going to hit enter. And so I told it kind of a left and right, and it found the max. And the maximum height of the rocket is going to be this y value of 2,939.36. Okay, I think that's feet. Okay. And then last but not least, we can use that to find out when it hits the ground. Well, when it hits the ground, I'll zoom out a couple more times. Okay, that is when x is 0. So we're going to call that, we'll go second calculate, and that's a 0, number 2. Now I know some of this is kind of new, and it wants to know the left, and then I got to come over here to the right. See that little red line? Now the right of where I want, and it finds the 0 at 23.5. Now, some of that is stuff that we'll get into more later, so don't worry about it if you're wondering what a 0 is and what a maximum is. We'll learn more about that later. But the main part is how to enter this in your equation, enter your calculator, and how to get a regression equation out of it. So we can use your calculator, or we can use Desmos like we saw there. All right, hope that helps.